Welcome to this video. So now we'll look at tutorial sheet 7, which is still on atomic structure. So there are 13 questions in this tutorial sheet. We are going to try to solve all of them. So we're going to solve all of them. Okay, so let's start with question 1. Okay, so question 1, they're saying define the following terms. Okay, so there's diagmatic, okay, paramagnetic, okay? They are magnetic, paramagnetic, and then valence electrons. So what is diamagnetic? Okay, so diamagnetic simply refers to substances, okay, whose atoms have no unpaired electrons in them. Okay, they have no unpaired electrons in them. So for example, if you look at beryllium, okay, if you look at beryllium, beryllium has an atomic number of 4. Okay, so meaning that it has 4 electrons. Okay, it has 4 electrons. So when you write its electronic configuration, it's going to be 1s2, 2s2. So we see that here there are no electrons that are unpaired, because this 1s simply means one box like this. And then even this s, okay, will mean one box like this. So this is the 2s, this is the 1s here. So in each of these orbitals, we know that we have 2 electrons, right? Which is these 2. So one is facing up, the other one is facing down. Here one is facing up, the other one is facing down. So when you remember what the magnetic spin number is, we said if it's facing up, it has plus 1 over 2, right? If it is facing down, it has minus 1 over 2. So if I have one facing up, one facing down, then the effects cancels out, okay? Because the minus half and the positive halves will cancel out. They just give a 0. So here we have 0 charge. Even here we have 0 charge, okay? So if we have such a substance, okay, that contains atoms that have no unpaired electrons, that's what we call as diamagnetic, okay? And the example is beryllium, or you can say helium, or even zinc, okay? It's diamagnetic because all its electrons are paired and none of them is what? Unpaired. So because all of them are unpaired, okay, I mean, because all of them have are paired, okay, all of them are pairs, meaning that there are no unpaired electrons, okay? These substances are going to be weakly repelled by a magnetic field. Okay, so if this is a magnetic field, so the magnetic field will be exerting its magnetic force. So if now I have this substance here, which is diamagnetic, okay, then the magnetic field, okay, or the magnetic forces felt by these substances here is going to be a 0. Okay, why? Because all the electrons are paired up. Okay, so that's what is diamagnetic. Okay, and then what is paramagnetic? Okay, so paramagnetic, it will be the opposite of diamagnetic. So paramagnetic, these are substances, okay, whose atoms have one or more unpaired electrons. Okay, they have one or more unpaired electrons. So a good example is sodium. Okay, so if I draw sodium, it will be like this. Sodium has it has 11 electrons. Okay, so its electronic configuration is 1s2, 2s2, 2ps, and then 3s1. So in this 1s, this is a box. We have one facing up, the other one facing down. In this 2s, similar situation. Okay, and then in the p, okay, for the p, we know that it will be a box divided into 3 parts. So 2 will be there, the other 2 will be there, the other 2 will be there, the other 2 will be there. Then the 3s, okay, it will be a box that just has 1 like this. Okay, so the magnetic spin number here cancels out. It's 0, here it's 0, here it's 0, here it's 0, here it's 0. But here we have 1 that is facing up, so it's plus 1 over 2. Okay, so that's what we mean by paramagnetic. It means that these are substances that contain atoms that have one or more unpaired electrons. We can see that this thing here is unpaired. Okay, so because it's unpaired, it's going to be exerting a force. Okay, because it's positive here, it's going to be exerting a positive force. So if it's in a magnetic field here, and then it has a positive force, this magnetic field will strongly be attracted to this because it has a charge, this substance here, okay? That's what I was saying here. Because of the paired electrons, they are attracted to a magnetic field. So a good example is the sodium, okay, that we've written out there, okay? Even the oxygen, the iron, the copper, they are also good examples of paramagnetic substances. Okay, so those are the definitions for diamagnetic and paramagnetic. We can look at the definition of the valence electrons. So valence electrons, these are just electrons in the outermost energy level, okay, of an atom. Okay, so if I write the electronic configuration of beryllium like this, the outermost energy level here is this level 2. Okay, so these electrons here, they are outermost electrons. So they are called valence electrons. So these valence electrons are very important. Okay, why? Because they are responsible for the bonding and the chemical properties of an atom. Okay, so they can be transferred if you are talking about ionic bonding, or they can be shared when we're talking about covalent bonding. Okay, so these valence electrons are very important. They're the ones that would determine, okay, the chemical properties of an atom. Okay, so those are the definitions in question 1. We go to question 2. They're saying, why do elements in the same group of the periodic table exhibit similar chemical properties? Okay, so these chemical properties here, remember, I'm just from saying that they are a result of the valence electrons. Okay, so if elements are in the same group, they always have the same number of valence electrons. So if this is group 1, all the elements that are in group 1, they will have 1 valence electron. So the group number tells you how many valence electrons, okay, that element has. So if it's in group 2, then it means that all those elements, okay, they will have 2 valence electrons, apart from the part for the transition metals. Okay, so maybe I should go to the, where's the periodic table here? Where's the periodic table? Okay, so the periodic table is here. So you've seen these groups here. Let's erase this. Okay, so these are the groups of the periodic table, right? Okay, these ones here. So these groups, we have group 1, group 2, and then we have this big block of transition metals. And then you say this is group 3, group 4, group 5, group 6, group 7, then group 8, or group 0. Okay, so all elements in group 1 here, they have 1 valence electron. Those in group 2, they have 2. Those in 3, okay, they have 3 valence electrons. Those in 4, there are 4 valence electrons. But immediately you reach 5, you're not going to say you have, oh, yeah. So this is 4 valence electrons here, okay? Then here on 5, it will be 5 valence electrons. And then on 6 here, oh, no. This is what I was saying. So we are saying these ones, let me be writing. So this one in group 1 have 1 valence electron, these have 2, these ones have 3, these ones have 4. And then this is, well, we're supposed to say they have 5 valence electrons, right? Okay, but we're not going to say that. So this one here is group 5. Okay, so group 5, it has how many valence electrons? It's going to have 5, because the 2, since this nitrogen has like 7, the 2 will be in the first shell, and then the 5 in the second. Okay, so 5 valence electrons. And then for the oxygen, we're going to have 6. For these ones, we're going to have 7. For these ones here, the valence electrons will be 8. So the group number tells you the number of valence electrons. Okay, so now why do these elements in these same groups have similar characteristics or similar chemical properties? Okay, here's the reason here. I was writing them down. So I said the valence electrons determine the reactivity. Okay, so chemical reactions involve the gaining, the losing, or the sharing of what? Electrons. So elements with the same number of valence electrons tend to react in a similar way. Okay? And then since they have the same number of valence electrons, even the bonding pattern will be the same. So because they have the same number of valence electrons, elements in a group often have similar types of compounds and have similar oxidation states. And then periodic trends reinforce the similarity. So The properties like ionization energy, we're going to talk about it, electronegativity, atomic radius, okay, change gradually down a group. But the pattern, okay, of the chemical behavior remains similar because the valence electron is the same, or the number of valence electrons is the same. So for example, in group 1 here, we have lithium, okay, sodium, potassium, they all have one valence of electron. So they all react in a similar way. For example, all these group 1 alkali metals, okay, they react vigorously with water. So if you get an element from group 1, you pour it in water, you're going to see a vigorous reaction, like you're just going to react like that. Okay, another example is group 17, or what we are saying group 0 or group 8 elements, which are not group 0, okay, group 7. Group 17 is the same as group 7. So these ones here, the halogens, they have 7 valence electrons. Okay, so they are highly reactive nonmetals, and when they react, they usually form salts. So if, for example, they react with sodium, from sodium chloride, which is a salt. Okay, so the reason behind those similar chemical properties is they have the same number of valence electrons. Okay, and then you can just try to explain it based on how many marks that question has. Okay, and then question 3, they're saying state 2 properties that distinguish the alkali metals group A from the halogens. Okay, from what I'm just from thinking about. Okay, so the 2 key properties that distinguish the alkali metals and the halogens are: 1, reactivity and type of elements. So the alkali metals, these group 1A elements, they are highly reactive metals. Okay, they are soft and they are also good conductors of electricity. So they react vigorously with water, okay, to form alkaline solutions and hydrogen gas. Okay, what about the hydrogens? The hydrogens are also highly reactive, but these ones are non-metals now. So they exist as the atomic molecules, okay, like C2, like Cl2, like this, okay, F2, like this. So they exist as diatomic molecules, and they react mainly by gaining what? Electrons from salts. So these ones, they react by losing electrons. These hydrogens, okay, react by gaining. Okay, so that was difference number 1, the reactivity and type of elements they are. And then the other one is the valence electrons and the typical ions formed. So for the alkali metals in group A1, okay, they have 1 valence electrons. So what type of ions do they form? They form cations because they tend to lose that 1 valence electron to form positively charged ions. And then when you talk about halogens, okay, they have 7 valence electrons. So they just need to gain 1 more electron to achieve a stable state. So the hydrogens, okay, they gain 1 electron to form negatively charged ions, which are called as anions. Okay, so those are the key differences there. And I've written them down here. In case you didn't get my explanation, you can pause the video, you read through whatever I wrote here. Okay, so let me erase for you. Okay, so you can now pause the video and read through. Let me go to question 4. So question 4, where question 4, okay, question 4. So question 4, they're saying explain why noble gases are chemically innate. Okay, so the reason why these atoms, these elements, the reason they react is to achieve a full outermost shell, okay, or to achieve a stable electronic configuration. So a stable electronic configuration, okay, is obtained when in the outermost shell, most of the times you have 8 valence electrons. So these noble gases here, okay, they are in group 8, we said there. So if they are in group 8, then it means all of them here have 8 valence electrons. Okay, so meaning that the outermost shell is already stable. Okay, it's already stable. So they don't tend to react with anything because they're already stable. The reason why oxygen reacts, okay, it's because it wants to gain 2 more electrons, okay, so that it can be stable. Because the electronic configuration of oxygen, okay, oxygen has 8 electrons, right? So the electronic configuration is 1s2, okay, and then we have 2s2, okay, and then I have 2p4 like this. So in this p orbital, remember we said the p always has to have 6, right? So that in the second energy level here, you should have 8. So here the oxygen has 6. So it always wants to gain 2. So that wanting to gain 2 is what causes it to react. Okay, so when it gets the 2, it will have the 6 here, it will be fulfilled, then it won't react anymore. Okay, so most of the electron of the atoms on the periodic table, okay, they all have an outermost shell that is not full, okay, or an outermost shell that does not have 8 electrons. So they always struggle to make those electrons 8, okay, by either losing or gaining electrons, okay. So now these innate or the noble gases here, they already have 8 electrons in the outermost shell, so they won't react because what are they reacting for? They're already stable. Okay, so I wrote down the explanations here. So I was saying these noble gases are chemically innate because they have a full outermost electron shell, also called a complete valence shell. So for a full detailed explanation, it's here. Okay, we're saying these noble gases have 8 valence electrons. Okay, except of course helium, which has 2. So feeding its own shell. So a full shell is very stable. Okay, the atom will have no tendency to gain or to lose the electrons. Okay, so if it has no tendency to gain or to lose, then there will be no chemical reactions that will be happening. Okay, because the chemical reactions depend on the valence electrons. Okay, so those are the reasons. You can actually read through here to have more understanding. Thank you so much for watching this video. Okay, if you'd like to access more videos on tutorial sheets and past papers, feel free to register with us. Okay, so in the description below of this video, you'll find 3 links. One is a registration video guide. It will guide you on how you can make an account and then register with us, okay, to access full tutorial sheet videos and full past paper videos, as well as topic what lessons. Okay, the other link is for the website, and the other link is for our mobile app. So on our mobile app, okay, you can actually download these videos and watch them offline. So you don't always have to use bundles when you are learning on our platform. You can easily get the mobile app. Okay, so just go on Play Store and then you search Discrete Learning Institute. The app will come, you install the app, and then on the app, you can download the videos and watch them offline. Okay, so check out the video in the description to know how to register. Once you register and then you go on our website, you're going to see something like this. Okay, so it depends with whatever you want. So if you want math, you register for math. If you want chemistry, you register for chemistry, just like that. Okay, so for example, if I open the course chemistry here, you want to find 2 folders. Okay, so if you're in semester 1, you go in the general chemistry here. Okay, so if you're in semester 2 Apex, you go in this folder. So semester 1, I'll open the general chemistry there. Okay, I'll find 5 folders. So this one here is for lessons and tutorials. So whatever topic that you're going to learn, okay, we have lessons in video form as well as summarized notes on all the topics. So you can see here all the topics, okay, from introduction to chemistry all the way to nuclear chemistry. We have the videos here. So you can watch these at your own time. Okay, and learn at your own pace, anywhere, anytime, even in your blankets. So here we have the handwritten summarized notes, so you can check them out. And then here we have the tutorial sheets. There we have the past papers. Here we have the lab report samples. So if you want to check out the past papers, okay, you open this folder and then you go to your university. So for example, if I'm at Apex, I'll go in the Apex folder. Okay, and then I'll go to the video solutions there. If you want, you can check out the written solutions. We also have them. Okay, so the video solutions, you're just going to find videos on different past papers. Okay, it can be quizzes, it can be tests, as well as the final exam. You're going to find the videos there. Okay, so these are the videos there. You can see some of them are for the exams, some of them are for the tests, some of them are for the quizzes. So you can use all these videos to learn at your own time, at your own pace. Okay, so these are the past papers. If I go back here, okay, if I go back here, I can now go to the tutorial sheets and assignments. So it's the same thing. You go to your university. So let me give an example. If I go in the Apex folder there, you're going to find different intakes. So you select the intake that you are in. Of course, you can also use the videos for the other intakes to learn, okay, because the concepts are just the same. So here I'm going to go into 2025 July what? Intake. So when I go in this folder, I'm going to find the video solutions to all the tutorial sheets that we've had so far. So these are the tutorial sheets here as well as the assignments. So the assignments, we have 4 written solutions, assignment 1, assignment 2, plus the video for assignment 1 here, the video for assignment 2 there. Okay, and then there are this tutorial sheet. This is 1, 2. Tutorial sheet 2 is divided into 3 parts. There's question 1 to 3, question 4 to 6, and question 7 here. Then I have tutorial sheet 3, 4, 5. This is supposed to be 6, but on the tutorial sheet they wrote 7, and then this one is tutorial sheet 7. Okay, and then from there we move to tutorial sheet 9. We had no tutorial sheet 8. Okay, so I'm going to upload here. Okay, once I'm done making this video, I'm going to upload tutorial sheet 10 on chemical kinetics. It's going to be there. So you can actually learn at your own time, at your own pace, using our platform. Okay, so you feel free to register. Okay, you can check out the link in the description below here to know how you can gain access to all these so that it makes your academic life easier. So remember, if you are facing a challenge in math, you can still register. You're also going to find the tutorial sheet, the past papers. If it's physics, okay, you're still going to find the tutorial sheets, the past papers, as well as the biology. So you can register for the course of your choice. Okay, so thank you so much for watching, and all the best as you prepare for your exams.